Nevo. It is now afternoon. Rates are here. This is going to be, if like geometries were like ruining your life, this is going, and like the names and symbols, this is going to ruin your life times 50. Okay? So basically, naming is so important because we need to know what we're talking about, but at the same time, it's like painful because you have to just memorize a bunch of stuff and how stuff works together. So, the last part of our previous section is on oxidation numbers. We did rules 1 through 4 already. So rule 5 is as follows. So this one's all about polyatomic ions. The oxidation numbers of all atoms in a polyatomic ion add up to its charge.
What is the X mean? OX? Oxidized?
Oh, it's not that word, is it?
Alright, so if we have like PO4 minus 3, the oxidation number of these have to add up to make that. It's kind of funky. Is it the one they used? It is not the one they used. So let's do OH minus. So here we have oxygen, whose oxidation number is normally minus 2, and we have hydrogen, which is normally plus 1, right? So if we add these, did I answer your question? Okay. If we add these, we get negative 1. So it works out, okay? What's annoying is that some elements will take very many different oxidation numbers. Obviously, the list that I gave you yesterday are the ones that are super friendly, like the alkali metals, the alkaline earth metals. All of the transition metals are weird and usually take more than one oxidation number. So I would encourage you to look on page 194 of your book later. And it is the periodic table with all of the possible oxidation numbers of each element. So hydrogen usually takes a plus 1 charge. Sometimes it'll take a minus 1, but that's rare. All the ones in the first group, plus 1. All the ones in the second group, plus 2. Some notables are iron, which either takes a plus 2 or plus 3 charge. Kind of interesting. Again, based on how it navigates that d orbital. Doing right? Mm-hmm. Cool. Cobalt, also plus 2, plus 3. Silver, always plus 1. Gold, I think it's weird. Plus 1 or plus 3. Mercury, plus 1 or plus 2. So there's a bunch of weird ones. You can see in the table there what these things will do. So that is our chapter on that. For homework, I'm going to give you the following. So section review 8A numbers 1, 2, 3, and 4. So that's on page 195. So your homework will be more review on that stuff than on new things. That I'm going to teach now.
195 or 191?
195.
Yes, questions 1, 2, and 34.
1, 2, 3, 4.
Oh, I counted.
I know. All right, so that is that. Now we embark upon naming. So all these compounds that we make, we have to name them. Okay, the oxidation numbers kind of dictate how they're going to fit together, but we have to give these things a name. So just like Mr. McKibben pulled one over on you today by asking you if dihydrogen monoxide should be banned, and we're like, absolutely, that's the worst ever.
I was like, it doesn't
Because
matter.
it kills people, and if you ingest it, you could die.
What?
No.
Yeah, like if you're
Too much of it,
underwater,
sure, that's how we feel.
under it, like you're in it and you're
Yeah.
breathing it in.
You get bronchitis or.
So you could be like, if you breathe in dihydrogen monoxide, you could die. Like, it's a classic trick of people who don't know how to name things. So I'm going to teach you how to name things. And the easiest ones to name, so this is section 8B. This is one of those things where you get your first quiz on it and you feel horrible because it's just hard. Okay, so just be ready, pay very close attention. If you like zone out, this is the wrong time to do so. Okay, so if you need to like go run a lap around the courtyard and come back, if you need to go get some coffee, like whatever it is, like go do that so you're ready to be engaged. So when we have naming, the easiest one is covalent compounds. Covalent compounds are the easiest to name because of the following. The way we name them is we are going to use Greek prefixes to indicate the number of atoms we have. So if you have one atom, then we use the prefix mono. If you have two, di, 3, tri, 4, tetra, 5, penta, 6, hexa, 7, hepta, 8, octa, 9, not to be confused with your grandma, nana. Oh, I didn't get a laugh there. And 10, deca. That's
Wait,
Oh,
fine.
What's number 5?
Such a sympathy.
They're all listed here.
Yeah, no, I can't read.
Penta,
Penta.
penta,
Oh,
I
pen.
don't say
Oh.
penta.
I was in
I wrote
Okay.
it down.
So, what we're going to do is we are going to put these prefixes in front of our element name, and then we are going to replace the end of our second element with ide, I-D-E, okay? So, for water, this is hydrogen, this is oxygen. So this is how we're going to name them. Step 1, mono, di, tri, tetra, penta, hexa, hepta, octa, nana, not your grandma, and deca. That would be nene in Greek. So, my shoe has come untied.
Did you see Mr. Franco got new shoes?
I did comment on that this morning. He said, my wife bought them for me.
Yeah.
I asked her what was cool. So, with that said, first step, you are going to add the prefix to each element, okay? So, there is one condition on this. We don't put mono on the first one. Okay, so the first element there, if there's only one of them, you don't put monhydrogen, whatever. We don't do it. So, you don't put mono on the first one, but you will on the second one. So, let's add our prefixes. So, we have 2 hydrogens, so it's dihydrogen, and we have 1 oxygen, which is monoxygen.
Oh, that makes so much more sense.
Okay? So 2 hydrogens, 1 oxygen, dihydrogen monoxide. So the second thing is you replace the ending with IDE. So oxide. So water is dihydrogen monoxide. What did I miss?
Wait, do you always replace the ending with IDE?
Yes, that's why it's step 2.
I don't know, I just feel like, oh, this is like for covalent.
Note, you always start with most electronegative. Least electronegative? Least. There we go. So in this case, hydrogen is the least electronegative, so we start with hydrogen. Oxygen comes next. Question.
Mr. McKibben say hydrogen dioxide. There's only one O.
Then he said it wrong. That's fine. He's a historian. Yes.
So start with electronegativity, is that, okay,
Usually it's written that way.
so you would have to work on the and then
You just have to have a general knowledge.
okay.
Yeah. Usually things to the left are less electronegative than to the right. What's up?
I was gonna ask, why don't we put the mono in front of stuff?
Because you don't.
Just 'cause?
So, I hate getting into history in this class, much like I don't like getting into science in history class. But as more and more compounds were discovered and synthesized, chemists realized that they could not continue to rely on memorized names. In the 20th century, the International Union of Pure and Applied Chemistry developed a systematic way to name compounds. This system of naming, called a nomenclature, are you writing all this?
No.
I'm answering your question.
Oh,
It's not.
yeah.
Nomenclature follows a standardized set of rules. The IUPAC, or International Union of Pure and Applied Chemistry, names of compounds are packed with information. They give the elements present in the compound, the type of compound, intermolecular attractions, and the general properties of the compound.
Sorry, can you repeat that one?
Some old dudes, Dylan, it must now be in your notes too, page 196. You can copy that down. Some old dudes got together and said, we can't keep doing this, and then made a system, and they decided that you don't put mono in front. And now all scientists everywhere are going to use the same system so that there is no confusion. Yeah, it's kind of like the metric system, except Americans decided that we don't care. So that's that. So let's try some elements. How would I name PCl5? First element is
Phosphorus.
Phosphorus. I was like, what's?
next element is
Carbon.
chlorine.
Wait,
Chlorine.
how is there 5 chlorine? Are you kidding me?
Because that's the element.
Because that is.
Mike.
Hey, Mike.
So, phosphorus, chlorine. Now, I'm going to add the prefix. So, we don't put mono on the first one, but we will put penta on the second one. Using the wrong color, aren't I? Ah. And we take off the ending and add I-D-E. So this is phosphorus pentachloride.
Why would you put?
Because that's what it is. That's it. I can't change its name. It's some old dudes decided on it. So this is the process. Yes.
So when you take the last letters off and add an ID, it's just the last 3 letters you take off?
Ish, like oxygen was 4. So you kind of get a feel for it. Whatever sounds right.
Okay.
Yeah. Those old dudes didn't figure that out enough. They give you one example? Seriously? That's dumb.
We have to revive them then. 'Cause
They only gave one example. What if we have more questions? What if we're like, I want to know more? What do we do? What do we do? I don't know. We keep flipping through the pages of the book until we find examples. Cool. So let's do. Never mind. I'll just make them up. That's easier. Whoops. All right. You just keep talking, man.
That was not Dylan.
No, earlier, not now. Now you're talking. I'm aware.
Wait,
All right, let's try this
You
one.
got so mad at me just now.
we're whistling
Not bad.
loud, babe.
No, you
I'm
were like,
smiling.
No,
There's
no,
videographic
I said-
proof.
I said, why isn't it?
Okay, here we go.
Because that's what we did.
That's true. I'm very mad. Administrator hat must be on. Okay, CO. You're familiar with this. It's called Carbon monoxide. It's bad for you. Please don't drink it.
Wait, Mr. Blanda, you can't.
So, we have carbon, we have oxygen. Okay, we don't put mono on the first one, but we do put mono on the second one. Then we chop off the ending and add IDE. That's how you get carbon monoxide. You can also get it out of your car. Yes?
So is there any time you wouldn't use I, or was it always gonna be?
These are for only covalent. So remember, covalent is non-metal to non-metal only.
Okay.
Good question. Excellent question, if I may. Let's get some more. That one's weird. That one's weird. There we go. That's fun. How about N2O2? N is
Nitrogen.
nitrogen. O is oxygen. Okay, we have two nitrogens, two oxygens. Ox.
Nitrogen dioxide. That does
That
not sound right.
Nitrogen.
Dinitrogen dioxide. Ditrogen. Okay, how about, those are all boring ones.
Wait,
Can't you come up with something?
Dinitrogen dioxide. It's as horrible as it sounds.
Nitrogen.
Okay, you good? Okay, let's try. Do we need more? Are you guys good?
No, we're good. I
Just-
think it makes sense.
I want like.
We can move on to,
Is that
You want to move on to the evil ones?
yeah.
What's up?
I was just wondering if we could do like one that's like Deca.
You want to do a deco one? A
I'm
decalogue?
just curious.
All right, let's try this one. No, I don't have one for you. Sorry, buddy. Okay.
Aren't you supposed to know?
How about this one? pH2. We can't do that one yet. I think this is it. We'll be good. So, here's the summary. Take the first element, take its name. Second element, take its name. Add the prefix, chop off the end. Sound good?
Yeah.
That's an easy one. That's why it does sound good. Okay, this is gone
Ms.
now.
Belinda, so
That's
step 2, where it says replace the ending with IDE, I put IDC, I couldn't.
Oh.
I don't,
IDE.
yeah. That's why I was asking the question earlier.
You got this. On a scale of 1 to you having this, you got this. Okay. Next, we are going to move to ionic compounds. So, ionic compounds are compounds where you have very high differences in electronegativity, usually metal and
Metal.
non-metal, right? That's what an ionic bond is. So, here is how we are going to do it. So, step 1, we are going to start with the cation, which is the positive one, then the anion, which is the one that takes the negative charge. Okay, so let's take one that we're familiar with. Na stands for
Sodium.
Sodium chloride.
Cl is
Chloride.
chlorine. Chlorine.
Chlorine, same thing.
Okay, so sodium chlorine. Now, what we are going to do is we are going to remove the ending and add the prefix "ide" to the anion. So we chop this off and we get chlor. I guess I could do it this way. Easy enough?
Yeah.
Yeah, might actually be easier than covalent sometimes, but it's usually not. Now, this only works if the following is true. If it is not, and if there's like no other obvious way for these two elements to work together, then you can simply write it like this. Now, what do I mean by that? Sodium is always going to take a what charge? Plus 1. Chlorine is always going to take a minus 1. What's the only way that they're going to combine?
NaCl.
Right? There's no question about how many sodiums to how many chlorines. There's absolutely no question whatsoever. If you have sodium chloride, sodium takes a positive charge, chlorine takes a negative charge, you have 1 and 1, you're set. The whole point of naming these things is if I say the name of it as opposed to saying like N2O2, if I say the name dinitrogen dioxide, you will know what the formula would be. I see your hand. It's okay. I'll get there eventually. Okay? So the name can be used to give us the formula, which will be one of your quizzes and much of your test coming up. Okay? Similarly, if I give you the formula, you should be able to give me the name. All right? They are interchangeable. You should be able to switch them up. Now, where ionic bonding gets weird is as follows. What's up, Brian?
Sodium and chlorine aren't metals though.
Sodium is a metal
How is it not? How is it a metal?
because it's an alkali metal.
Oh.
It likes to give up electrons. Remember, metals like to take a positive charge and give up their electrons. So it's a metal. Isn't that great? It doesn't feel metally, huh?
Yeah.
You want it to be like more like aluminum, more like,
Yeah, because you can't make a sheet of sodium.
eh.
Maybe at Burger King. you can.
But remember, all of those metals don't have the same properties.
I'm lost.
All right, whenever you're ready. That's fine. You should do a comedy class. You can get all your comedy out there. Remember that the alkali metals and alkaline earth metals have different properties than the transition metals, which are the ones that you're more familiar with, like iron and silver and gold and copper. Okay? So the alkali and alkaline earth metals are completely different. So like you don't think of calcium as like being put in wires for people's houses, right? You think of it as like the stuff that builds up on your shower head.
But
So-
it's metal?
It's a metal
Yeah.
because it likes to give up electrons. That's what a metal is.
So
Okay.
it's not necessarily.
That's it. It's not like they don't all have the same properties. It's okay.
So
Like
there's
most of the
liquid-
periodic table is, can you raise your hand? All you have to do is raise your hand if you have a question. It's okay. Yeah, mercury is a metal and it's liquid, right? So they all have different properties. It's okay. Question.
But it can harden.
It can if you cool it, but anything can become a liquid eventually. You just have to heat it up in there. So, all right. So here's where it gets ugly. What if I wanted to represent this compound? Fe is
Iron.
iron. O is
Oxygen.
oxygen. By this definition, I've said that you chop off the ending and put IDE. But the problem with that is that iron, as mentioned earlier, can take what charge? Look at your notes. It was like 5 minutes
2
ago.
or 3.
Iron can take a +2 charge, or it could take a +3. So, by this definition, I would call FeO iron oxide, but I would also call Fe (2O3) iron oxide.
I'm confused.
The if I have 2 irons and 3 oxygens, they still match up, right? 2 times 3 plus 3 times -2 is 0. If you add up the charges, right, you have a +6 charge here, you have a -6 charge here, which equals 0.
So technically that's still the same.
Yeah, and so the name is trash. Right?
It's actually.
Like this name is trash. Yeah, it's not legit. Doesn't exist. There's no iron oxide. Why? Because it could refer to both of these. So, if there is an opportunity for us to have an ambiguous case, we have to specify the charge on the cation. Okay, the way we'll do that is we'll indicate using parentheses and Roman numerals. So the last step, which I'm going to put here, which is really going to bother you, but it's going to make my notes look nice, is that if the charge on the cation is ambiguous, which means you don't know what it is, you specify the charge in Roman numerals. So if you don't know the charge, you have to specify that charge in Roman numerals. So what does this mean for you on a test or quiz? If I say, well, give me the formula for iron 2 oxide. That tells you that you have iron with a +2 charge mixed with oxygen, which usually takes a -2 charge to make FeO, which would be your answer. But if I said iron 3 oxide, and knowing me, I'll probably go for that because it's more difficult. You would know that iron is taking a +3 charge and mixing with oxygen, which is a -2 to make something. What's the only way to get these to balance out? You have to multiply this by something, multiply this by something to make an atom that will equal 0. Easiest way to do this, you have to kind of think back to your common fractions, right? You want them all to have at least common fraction. What's the least common multiple of 3 and 2? 6, right? They all multiply into 6. So if I can get this to give me 6 electrons, and I can get this to give me 6 electrons, then I'll have Fe2O3. There's 2